All right, good afternoon. My name is Sam Atkinson. I'm a senior software development engineer at AWS. I've been with Amazon for about 5 years, mostly on Amazon FSX, which offers OpenZFS as one of its offerings. So I'm going to be talking mostly about OpenZFS in the context of that and its relationship with AWS. Some of the things that we've learned and been challenged by in the last year, and some of the cool things that our customers are doing with OpenZFS on AWS. So for those of you that were here last year, my colleague Stabdi presented on the same service last year. So I'm going to do a quick refresher on what is FSX for OpenZFS, what is FSX, talk about trying to focus on some of the new additions, and then how we've operated OpenZFS, some of the things we've learned, and what cool things our customers are doing. So FSX was first built in 2018 to serve a gap in AWS file storage. We had cloud offerings for file server or for file storage in AWS already, but realized that there's, like many things, not a one-size-fits-all solution. So we built FSX, File System X, where X is your choice for your workload. It's your type of file system. And so today we have 4 offerings in FSX: Windows, File Server, Lustre, NetApp ONETAP, and of course, FSX for OpenZFS that I'm going to be focusing on today. So the goal, with FSX is just to combine the best of AWS and the best of these industry standard, some of the most popular file systems out there. We fully manage them, we administer them, and then we pass on all of the benefits of AWS that you're probably used to: high performance, durability, security, cost effectiveness, etc. So why bring FSX for OpenZFS into this? Of course, choices were out there. Why this one? So we looked at some of these customer workloads that maybe didn't quite fit into the mold of other file storage services in AWS. Some of them listed here. These high performance databases, source code version control, ML, AI, EDA. We kind of noticed some patterns in these where it really came down to 3 things. First, a lot of these workloads, a lot of these customers needed extremely high performance, very latency sensitive in a lot of cases. They were a lot of times needing NFS, and they a lot of times didn't need the full suite of enterprise features that you'd get out of maybe an ONETAP or a Windows. And so there's an opportunity there to give a little bit of a better price performance ratio with a different offering, and thus we brought in FSX for OpenZFS to fill those capabilities, and then also provide some of the enterprise oriented features that OpenZFS makes available today, quotas and compression, etc. So couple just given things, that NFS, the familiar data access, customers were used to it, needed to remain NFS. So they have their their infrastructure in AWS, in an AWS virtual private cloud, and they just need to drop in a replacement for NFS. And so we bring in FSX for OpenZFS there. I'm going to talk a little bit more about the performance and how we deliver that, but just high level, this is kind of what we're looking at, the performance that we deliver on our top end today. Because we sort of went into this with the tenet of trying to balance simplicity with capabilities and performance, etc. We chose to integrate most of the FSX OpenZFS, or most of the OpenZFS features, make most of those available via the AWS APIs. So the Amazon FSX service has a set of APIs, just like any other AWS service, where you can choose to configure different parts of your file system, do things like enable different types of compression, change record size, many things that you'd be used to doing in common ZFS tooling today, libZFS, etc. So we picked this set just because customers asked us for it, the most. It was most important to them. It's not exhaustive, obviously, but it's the set that was most important to them, and so it's the set we brought into our API. So it's kind of the overview recap of what Stabdi talked about a little bit last year. So what's changed in the last year? A couple new additions. So previously we had a single AZ, a single availability zone deployment. It was not highly available, just essentially a single file server in a single availability zone that delivered great performance, but we improved on that this year. We improved on the hardware with what AWS made available internally to us, and that we wanted to pass on to our customers. So it looks something like this now. Performance primarily dictated by a front end and a back end link. Of course, front end being to your NFS client, and then back end to a virtual disk in AWS. One of the really compelling things for customers in this is that backend link doing 80 gigabit per second. It's 10 gigabytes per second sync write, persisted to disk, which a lot of customers have been really happy with, being able to deploy that rapidly, and get that kind of performance. You'll also see we've added L2 ARC. We didn't have an offering with that last year, and so being able to take advantage of the L2 ARC with 170 gigabit per second front end link, it's also been pretty advantageous for a lot of workloads. And then we've introduced just a few months ago a multi-AZ, multi-availability zone deployment, which is highly available. And so this is an active passive configuration where we have an active in one availability zone, one group of data centers, and passive in another. Again, we have the same backend link that's dictating a lot of the performance. And on the front end, we have a router deciding which is the acting primary, and then we perform replication again also over a 170 gigabit link, and that permits the full 10 gigabytes per second sync writes to durable disk, even in this multi-AZ offering. So just kind of what it looks like when we have a failover, say availability zone A is, or at least the file server in availability zone A is down for maintenance, what have you. We're failing over to make the file server in availability zone B the acting primary, and issue all rights there, where afterward we'll see resynchronization and the preferred primary fail back. Another new addition, we had a lot of customers ask for this, was a CSI driver, a container storage interface. This is used in a lot of Kubernetes-based container workloads. It just makes it easier to provision, manage shared storage in one place. It's just a common pattern in a lot of these Kubernetes-based workloads, so that they don't need to work with a bunch of different sets of APIs and frameworks to provision storage and servers and software, et cetera. It's just all in one place. And so we built this. It's open source. You can check it out. It just allows you to do things like choose which storage you're sharing within your cluster. Static and dynamic, just meaning you can choose an existing or create a new OpenZFS F6 for OpenZFS file server yourself. Choose mount options, NFS mount options, take snapshots, restore from those snapshots, all of which is just a natively supported thing in the CSI driver, and then resize your file systems. That's containers have exhausted all the available storage. You can increase the size of your total file system with the same CSI driver. Lastly, in terms of just new additions, telemetry, we already had telemetry for storage utilization by data set, compression ratio, throughput, and IOPS utilization. We've since added just customer visible metrics for CPU and memory. Just keeping with that balance of simplicity and performance and ease of use. We added these in because we realized that there was more than one signal that customers would sometimes need to know when they exhausted the capability of their provisioned file storage. It's not just those, that front end and back end length that's dictating what they see as performance. Sometimes they need more memory. Sometimes, thrashing the arc. Sometimes high enough IOPS workload, you're utilizing all the CPU you have. And so we started giving that to our customers. So that's our new additions. Using F6 for OpenZFS, it's because it's all in the AWS set of APIs. You'll see a simple command line interface like this, where in this example, I've just chosen to provision 400 gigabytes of storage with a throughput capacity of 128 megabytes per second. After a few minutes, I will see a fully available file system that I can now work with, etc. So my response here, you'll see I didn't provide a disk IOPS configuration, but just for workloads that maybe have not as much throughput needs, but are more IOPS oriented, maybe a database or database-like workload where you might need more disk IOPS than you would otherwise need, small IOs, that kind of thing. You also see this root volume ID, which is it's a kind of a weird thing that it's called a volume, but it's an overloaded term. The volume in FSX is an equivalent to a file system data set in OpenZFS. And so this root volume ID is the root data set on a Z pool. And so on Amazon F6 for OpenZFS, that Z pool is always called FSX. And so your root data set is always /FSX. So if I want to expand on that, I want to create a child volume or a child file system data set from there. I can choose to pass in that parent volume ID to a create volume call, choose a compression type, choose a record size, choose a name, and then I'm getting back a volume path, with that /FSX. I've created a child volume, and within a minute or two, I can use that. You'll see I can also set some manifest export options here. It's very similar to what you'd see if you were provisioning your own NFS server on Linux, very similar. Change your server-side mount options, make it read-only, make it async, do whatever you want. Choose the networks that are allowed to mount this volume, this file system data set, etc. So another thing you can do just in terms of administration is manage maintenance and patching. So we manage maintenance during a maintenance window of 30 minutes. It's once a week. You can update that maintenance window. What are we doing during that? We are doing routine software patching, security vulnerabilities. We're upgrading the OpenZFS version after sufficient review. Performing any hardware maintenance needs to be done. We're doing that. How are we doing it? With our new multi-AZ offering, we're just doing the failover that I showed you, which is a less than 60-second IO pause. So your workload is just seeing a pause, it's not seeing failures. And so that's patching. How are you protecting your data? You are doing it most likely in one of two ways. You're either using an OpenZFS snapshot, which is something that will only exist as long as your FSX for OpenZFS file system exists. You delete your file system, your snapshots are gone. It's a single data set, read-only, instant, obviously, all that good stuff. The file system backup, a little bit different. That's a storage layer backup of the entire file system. Any data sets, any snapshots, any compression settings, all of that is contained in your backup. That's stored in S3, a little bit higher durability, the notorious 11 nines of durability in S3, and that will remain after your file system is deleted. So tons of flexibility there. If you're only running your workload at certain times of day or sometimes week, you can take that backup, do with it what you will. It costs less, move it around to different regions, share it with different people, and then spin it back up when you're ready to resume your workload. So operating this service, we've learned just at scale mostly meaning just the sheer number of file systems that we're managing. that it's impossible to do all of this with automation. Obviously, there's always bugs in every kernel upgrade, and not always in every OpenZFS upgrade. A lot of times there's not, but it's never, things are never perfect, and our automation is never going to catch everything. So we automate what we can. We spend a lot of time working on automated monitoring tools that run on file systems, monitor file systems, and then we spend a lot of time building sufficient internal metrics and dashboards that we review on a daily basis. We're looking for phase changes in performance, looking for outliers in metrics, and then going and investigating where it feels appropriate. Some of the learnings and challenges. So just automated testing and qualification. When we're getting those new OpenZFS releases, we feel that OpenZFS upstream release velocity is high. It's fast, and that probably might be a surprise to some of you that feel that way. But there's a lot of file systems out there that we offer that don't have near as high of a release velocity. So keeping up with that, building testing automation to pull those in is hard. It takes time, and so we've had challenges with that, and luckily we've found regressions before, small regressions that were of no impact to any customer of ours, but it's hard. So we've been working on building automation to pull those in and sufficiently test and qualify them. So we're constantly upgrading and patching existing file systems. So making sure that a new OpenZFS release is going to work with the block layer layout of an existing file system. Obviously, something that is tested by all of you for the most part, but we do the same just to make sure that for any file system out there in the wild for us, that still holds true. User and group quota lookup. This is just an interesting challenge that I wanted to share. We had a problem a little over a year ago. We noticed that some specific testing workloads we were running were causing a deadlock in ZAP Blockter on ZFS writes. This was super small write IOs, extremely high IOPS. A lot of times we would see it more often with really compressible data. So we're hitting ZFS write really hard, and so we started seeing this deadlock. We'd only ever see it in this code path within ZFS IDE over block quota. So we submitted an issue report. If you want to learn more about the deadlock itself, you can go there. But we decided this year to sort of step back and ask, like, why are we only seeing this in this ZAP lookup in ZFS IDE over block quota? So we used some BPF tooling, which was fairly new to a bunch of our team, to start looking deeper. So we try to figure out what else is using the ZAP here. Why are we never seeing this deadlock with anything but ZFS IDE over block quota? So we find, okay, there's only 4 objects here that are being queried for a ZAP lookup in this, ever in this test, and we found that, okay, these 2 objects are indeed the user group and project quotas. And we were confused by this because we don't, in this test and in these file systems we were spinning up, we were not using user and group quotas. So we were, confused why there would be a synchronous lookup of the quota usage during every single write, which is what it looked like. So, just to be sure, we did just another little one-liner BPF lookup here to make sure that we were only seeing this in ZFS IDE over block quota, which we were, and so we were wondering what's going on. So FSX, as you saw when I ran that create volume command earlier, is defaulting user and group quotas to be unlimited. And in our automation, what we're doing is no matter whether the user passed it or not, we're passing a value down to ZFS to set the user and group quota. So that meant we were explicitly setting a user and group quota to be unlimited if they didn't provide it. So every single file system had a ZFS set quota command run on it. And so we were explicitly setting user group quotas, meaning the quota zap object was explicitly being created and then checked in every write, even though we weren't using quotas at all. So we submitted a pull request to make that behavior consistent so that when we, when we create or when we tell ZFS to create an unlimited quota and all there are unlimited quotas, we can just drop that that zap object. Same with, if I had a legitimate, non-zero, non-unlimited quota and I got rid of it, again, it would drop the zap object if I got rid of it. So the other big impact this had was on performance. So whenever we would see this deadlock, we're completely just totally locked up on CPU because everything's just spinning on this debuff find lock. So the flame graph of CPU looked something like this. And so we were, performance at that point was completely bottlenecked just on CPU. And so afterward, with these quotas actually disabled, we were seeing some huge differences in performance for this specific type of workload, where we were, when we had compression or when we had quotas completely disabled, we were seeing some, up to 3 times the IOPS achieved on sync writes, double the throughput in some cases on sync writes. So it was a big, for a lot of our customers that aren't using group quotas, this is a big improvement. Yeah. So let's talk a little bit more about our customers. Just coming back to these types of workloads and patterns. Again, these databases, these small I/O, really latency sensitive workloads, the dev tests that are requiring that like snapshot clone pattern. What are they looking for? So top 2 here are sort of things that we can work on and are on our radar. A lot of times we see customers wanting more insight into that disk, that backend link. What is our utilization on that actual disk? I don't want to just know how many IOPS ZFS is doing or how many bytes of reads and writes ZFS is doing. I want to know what the disk is doing because it's not always the same. The other is more flexibility with snapshots. They want to be able to move snapshots around, do full, non-clone copies of them, move them from file system to file system, back them up forever. So we've had a lot of customers ask for that. The bottom 2 are ZFS, more OpenZFS related challenges and asks, maybe some of which, and we'll see if I don't know, I'll give them a shot tomorrow maybe. But default user and group quotas, just being able to set a quota for any user ID, GID that doesn't match one that they provided. And then user and group quota utilization visibility. This one I think is interesting because it's, it's sort of a gap in the, what we expose in the API versus what ZFS tooling and libZFS exposes today, where they can set these quotas in the API, but getting them is much harder. Because we're not exposing the entire file server to them, libZFS to them, utilization visibility is hard. And so we've looked at, different ways of maybe doing that in .zfs directory, maybe. We'll see. I'd love to chat with some of you about that. But that's something that the customers have asked for. So let's talk about 2 big customers that we have that are kind of exciting workloads. Life is Tech is in, they do educational services. And so they offer file storage for a lot of elementary and junior schools in Japan. So they have these small file workloads that are a lot of times driven more by their students than them, but performance matters, latency matters. I think, the users in that space maybe a little bit less patient maybe. So this, latency mattered to them, performance mattered to them, and they were hitting bottlenecks on their existing storage system. So they moved to OpenZFS, to F6 for OpenZFS. They achieved that stable performance they were looking for, lowered their operational load because they weren't having to do patching, weren't having to do backups themselves, all of that. And so they're one of their SRE group managers here was talking about how they improved performance by 90%, reduced cost by 75% over their previous offering, and then we're able to, really simplify scaling the performance of their file system during different times of the year, and changing scaling the storage capacity as needed. So did this for about 500,000 students across Japan. The other is Vela Games. They're a game development company that does a lot of their builds in the cloud. So they're doing a lot of cross-platform builds. They're doing a lot of parallel builds where they're trying to use the same artifacts in multiple builds. And so they use this build graph tool to help coordinate these jobs, parallelism, and cross-platform builds. And their storage system was becoming their bottleneck. So they moved to F6 for OpenZFS. And they were successful in delivering the performance and latency and cross-platform access that they wanted, being NFS, just giving that cross-platform access. And so they were able to have success there. And their technical director here, infrastructure and operations, talking about how they parallelize, reuse assets quickly, just with snapshot clone pattern. And then they were able to cut down their build time by 60-ish%. So what's next? We're looking to get more engagement with the community. We've tried to do that a little bit, in the last year. I know Stabdi, my colleague, mentioned that a little bit last year, keeping up with issue reports that are relevant to us. We're trying to get more AWS engineer hours in OpenZFS code, which is challenging, but we're picking up on that. More upstreaming bug fixes and improvements. We went over a couple, but trying to get even better about that in the future. And that's it. So any questions?
Yeah, so I have two questions that I wanted to ask. The first is, are you using any ZFS storage configurations on your backend, or are you just relying on your own internal resilience and redundancy features?
So yeah, for redundancy and durability, we're just relying on underlying internal AWS storage services.
Okay, and then the second one is you talked about how you have snapshots as an option within FSX, and then you can do a whole pool backup into S3 as your alternative backup solution. Yeah. Have you considered persisting single snapshots in S3 with something like set and receive?
Totally. Yeah, I think we've considered that. I think it's something we'll absolutely consider doing in the future. So yeah.
This failover, right? From one zone to another. Is that to deal with a problem or?
Just high availability. So in our existing single availability zone offering, if we, for example, were doing maintenance, if we had a hardware failure or needed to patch that single file server, customers are seeing up to 10 to 20 minutes of potential downtime during that. And so with the multi-AZ offering, they're getting a pause instead of a downtime.
Meaning you have observed issues.
I mean, in AWS, just the scale, these failures do happen in availability zones. And so generally customers are, we talk to them about architecting in a way where if they need their workload to be highly available, if they have, customers that are using their product 24/7, architecting across multiple availability zones. And so it's a common solution to that problem of, when a failure happens for whatever reason, it could be a single drive failure, it could be a memory module failure, just having the entire thing fail over to a secondary availability zone.
Okay. So what in our company, what we are doing is that sometimes we're facing the issue of idle. So basically that's caused by architecture.
Mhm.
During that time, with the problem happens, like we got a high with like 40% something.
Mhm.
It's terrible. During that time, we were slow response.
Yeah.
Problems aside.
I think we used to. I know Satabdi last year actually spent a couple of slides talking about all the tunings we did on ARC because we did have some trouble with that initially. With ARC utilization and pruning causing issues sometimes, but we put in a lot of time into tuning these just right for our different configurations, and we've since taken care of that problem. So we haven't observed that with customers lately. Unless their customers will sometimes see if they say under provision their file storage, their file server, they'll see it, but we've pretty much taken care of that with what's talked.
So your live is the zipper is built on the physical file, but not the AWS virtual file.
The pool itself, the persistent storage is on the AWS side virtual drive.
Oh, virtual file, not the physical file.
I mean, it's backed by physical drives.
I know.
But yeah. But it's an AWS internal virtual drive. Yeah.
Okay.
Two questions. One on the performance side. So you had a slide which showed 1 million NFS IOPS, right?
Mhm.
So given your backend cannot do that, so I assume that's all coming from cache.
Mhm.
And is that on a single instance? If it's like, is it a single EC2 instance it serves that?
Yes, it can serve that to a single EC2 instance client, for example, if that's what you mean.
No, on the server side. So
The hardware we use, we don't usually disclose like what the hardware is. It is a single server though.
okay, got it. Second question for the HA solution that you have, do you use safe assembly for replication?
I can't disclose that one either, but we do fully synchronous replication, so a sync write when it's on both disks in both availability zones. Sure.
So you're talking about your, so you did some testing. You do some testing when you pull in ZFS F6. Is that primarily performance testing that you're concerned with, or is there any other kinds of testing that you do?
There are a couple of logical tests that we do, but they're mostly for things that we've run into in the past where it's like we never want to hit this again. We make sure we have a test for it.
So have you considered pushing those kinds of things back upstream to the community?
We've talked about it. Honestly, that is probably some low-hanging fruit that we could do. Yeah, it is a lot of mostly performance testing, but still, it's a lot of it. We're driving the workloads with public AWS hardware in most cases, so they could still apply.
So which Linux are you running OpenZFS in?
The Linux version, I can't say that either. I can't disclose that. We run Linux, but
you put it into that Linux. It's not the ZFS that comes with it.
Correct. All right.
Thanks a lot.
Thank you.